Today I am dealing with wave optics. Wave optics. Especially I will be dealing with the single slit. Single slit. This I have done as per the requirement of my students. So I have done this. Here the single slits for wave optics. Here we have considered a slit. Say this is a slit. We have considered a slit here, and this is the source of light. Here this is the source of light entering through the slit. Means actually the single slits. I am going to explain about diffraction. That is the diffraction of light. Going to explain about the diffraction of light and the single slit. Now here, let us see what happens. This is the source of the light, and this is the midway between the two slits. Here this is L and this is N. Midway between the two slits. And here we have taken a point P, that is the point of observation. Now, again I am telling you that this is a single slit, wave optics, and this single slit, that means I am going to explain about diffraction of light. So here you see that in the single slit, so this is the slit, and here this is the source of light. Now here this is the point P, point of observation. So the straight line, here this is a straight line here. So point of observation, so rays of the light, this is the point of observation. Let us this take as M. This is L, this is N, single slit. Now we have taken this point of observation P. So here all these are parallel, so it is making an angle theta, here theta, and here angle theta. Now I draw a perpendicular from L to N. I am drawing a perpendicular from L to N to this line. Let this be Q, let this point be Q. So let this point be Q, this is perpendicular to this NP. So let us, I am making a little bit enlarged version of this. So here you see this is the slit. Here you see this is the slit. This is the slit. This is the slit. And this is the source of light here. Source of light here. And here this is the M. And this is L. And this is N. Now, these are all ray diagrams, straight line, and now this is the point of observation P. So here all this line P are parallel, all these lines are parallel. So each of them are making angle theta. I am thinking that it's making angle theta here. Now I am drawing a perpendicular from L to here on this line. Let this be Q. So clearly here you see that NQ, you clearly see that NQ is the path difference. It is the path difference, that is NP minus LP. This is the path difference. Here you see clearly this is the path difference. Now here you will find that this angle, will be also theta. you can calculate it. This angle will be also theta. And the slit width be A. Let us take this slit width be A. Let us take that the slit width be A. So here you see that this NQ, this NQ will be equal to A sine theta. You can, because sine theta, this is the perpendicular, so sine theta will be perpendicular by hypotenuse, that is NQ by Ln, NQ by Ln. So here your Ln is A, so here you can see that sine theta will be NQ, this is NQ by Ln, and your Ln is NQ, Ln is your A, so your A sine theta, your A sine theta will be NQ. Here you see this will be NQ. So therefore the path difference is A sine theta. And if theta is very small, then we can consider, if theta is very small, then we can say that it is A theta. If theta is very small, then we can say that it is A theta. Now again here you see, this is the slit, this is L, and this is N, and this is M. So if we take a point here M1 and another point M2, let's take M2, this is M1 and this is M2, this is M1 and M2, and the distance between M1 and M2 is Y, if you take Y. So here again, for these two, even for these two, your path difference, that is M2P minus M1P will be your Y theta. M2P minus M1P will be your Y theta. So what actually they want to tell us, that is the relation between path difference and the slit width. So if your slit width is Y, then your path difference will be Y theta. So if your slit width is A, so your path difference is A theta. So this is what they want to first of all tell you, that is the relation between path difference and the slit width. This is the what they first of all they want to tell you. Now at this central position here, C, at this position C, your theta will be 0. So all this from anywhere between L and N, anywhere the light waves will be in phase at this point C. From all this from between the L and N, all the light waves will be in phase at point C. So at point C you will get maximum intensity. At point C you are going to get maximum intensity. Because theta will be 0, and all this point from the light wave will reach here at the same phase, and you will have maximum intensity. They will be the same phase. Now here the next question is here, that means at theta is equal to 0, you are going to get the maximum intensity. Now if your theta is n plus half lambda by A, it has been told here that if your theta is n plus half lambda by A, you are going to get maximum intensity. And if theta is equal to n lambda by A, then you are going to get minimum intensity. So this has been stated that for theta is equal to n plus half lambda by a, we are going to get maximum intensity, and for theta is equal to n lambda by a, we are going to get minimum intensity, where n it is an integer. This n, it belongs to integer, z belongs to integer. Now, first case they have taken here the first case for they have started with minimum intensity. So first they have taken here they have taken one thing, that is for minimum intensity. Here they have taken theta is equal to 1, and for value of n is equal to 1, that is equal to lambda by a. So here theta a is equal to lambda. That means theta a, it is the path difference, and they have considered the path difference to be the wavelength, difference in the wavelength between the two waves. They are going to take the difference between the two waves, that is the path difference. They have taken it as lambda. They take it as lambda. So here what happens if we take 2 points here, m1, if we take 2 points m1, let me draw it again here. Let us take 2 points. Here you see L, M, L, N, this is N, and here this is the point M. If you are taking here M1 and taking this as M2, 2 points, means this slit has been divided into 2 parts, LM and NM, and for any point M1 there is a point M2 in Mn. For means for any point, that is for any point M1 in LM there is a point M2, there is a point M2 in M. So now here we have considered that it is in the midway between these two. It is in the midway between these two. So here this is a by this is length a. This length is a. So this will be here. It will be a by 2. So from here to here it will be a by 4, and from here to here it will be a by 4. So this distance will be a by 2. So now here your slit width has become a by 2. Now here your slit width has become a by 2. That means your slit, this slit width is a by 2. That means here this is divided into 2 equal parts. So here this is slit width is a by 2. So when the slit width is a by 2, so your path difference will be your your a by 2. So your theta will be this here your path difference, or your path difference will be a theta. So this will be how much? Your a is slit width is a by 2. Theta. Slit width is a by 2 theta. Because here already we have found the relation between the path difference and the slit width. Now your slit width is a by 2. So your path difference is slit width into theta. Now what is a theta? You have considered a theta is lambda by 2. A theta is lambda by 2. So what has happened here? That is these two light waves have reached the point P. From these two, the light waves has reached the point P such a way that for the upper half it is and the lower half, for the light waves from this upper half and from this lower half, they are out of phase. They are out of phase. That means they are out of phase. They are out of phase. That means your they are out of phase. Out of phase. So here there will be minimum intensity. So here there will be minimum intensity. So they have here, it has been already told you that for theta is equal to n lambda by a, it has been already told you that theta is equal to n lambda a. This will be for minimum intensity. This will be for minimum intensity. Minimum intensity. This will be for minimum intensity. Minimum intensity. This will be for minimum intensity. This has been told for you. So here for theta is n is equal to 1. That means the path difference is lambda. Here we know that it is the minimum. Here the intensity is the minimum. But why minimum? This has been explained here. Why minimum? This is minimum we know. This is minimum. This is minimum intensity we know. This is minimum intensity we know. But why minimum? Why minimum? Why minimum? This has been explained here. Why minimum? This has been explained here. Because these the two light waves, they will reach at the point P in such a way that they both are out of phase, and so out of phase it cancels out and it is minimum intensity. So remember what I want to tell you, what is given in your book. This has been already told you. Next, the path difference, the formula has been already created for you. So it has been told that if m1 and m2, if m1 and this distance is y, then your path difference is y theta. So here again your path difference is a by 2. So your path difference is So your path difference will be a by 2 into theta. So here this we know that it is the minimum intensity, but why minimum intensity? This has been explained here, because from m1 and m2 when they reach the point, they will be out of phase and the intensity will be minimum. This I want to tell you all. Now again they have considered, now again in your book it has been considered that for maximum, let us consider for maximum intensity. Let us consider for maximum intensity. We know that at theta is equal to 0, it is the it is a maximum intensity. Now let us consider another point. So we know that theta is equal to n plus 1 by 2 lambda by a. Here it is the intensity is maximum. We know that intensity is maximum. We know about it. So for n is equal to 1, theta will be equal to 1. That is 3 by 2 lambda by a. This is 3 by 2 lambda by a. So what they have done, they have divided this slit into 3 equal parts. This divided the slit into 3 equal parts. So your 3 equal parts, each part will be a by 3, a by 3, a by 3. They have divided the slit. They have divided this slit into 3 equal parts. So each part will be a by 3, a by 3. Now they have considered these two slits. So your distance will be 2a by 3. Your distance will be 2a by 3. Now your distance between the slit is 2a by 3. So what is your path difference? So what is your path difference? So what is your path difference? Your path difference is slit width into theta. So this will be your path difference will be what? Your path difference will slit width 2a by 3 into theta. This will be your path difference, slit width into theta. So here again you see that what is your theta? Theta is your, that is 3 lambda by a. I am going to place here. So 2a by 3 into 3 lambda by a. This is your theta. Here this is your theta. So here you see everything cancels out and it is lambda. So when path difference is lambda, I have already told you that is the minimum intensity. When path difference is lambda, it is minimum intensity. So here the intensity is minimum. Minimum intensity. Minimum intensity. Here the intensity is minimum. So only it is left here is A by 3. So the only slit is here is A by 3. So here you are going to, because of this slit, the light will move and you will get a maximum intensity. But since here only the light flows through only through this slit, so then you will get maximum intensity, but the amplitude of the maximum intensity will be less than the amplitude of the maximum intensity formed at point C. Your intensity will be less than the amplitude formed at point C. So here, so we are getting a graph. The output is like this. We are at the center C. We are getting maximum intensity, and after you see the intensity decreases. After that you see that your intensity decreases, and here you see that is the intensity decreases. Amplitude, your intensity, here you see the amplitude decreases. So here this part, we know that this is maximum, but why your amplitude decreases? This is the reason they have given why the amplitude decreases, and your output will be like this. So this is all about single slit. I have done it because my student wanted to in details, so I have done for them. So here I am repeating that it has been already told you that they have derived a relation, that is the path difference and the slit width. They have derived a relation, and they have already told you that for theta, when theta is equal to n lambda by a, it is minimum. It is minimum. And when theta is equal to n plus half lambda by a, it is maximum. And at the center, because theta is 0, from all these points between A and L, all the light waves will reach here in the same phase. So here it is, intensity is maximum. This has already been told you, but the one they want to tell you that at that is when here theta is equal to lambda by a, that means theta a is equal to lambda, your intensity is minimum. Why intensity is minimum? That has been explained to you. And again, when you take theta is equal to 3 lambda by a, here why the amplitude of the next maxima decreases? Why? So they have explained to you. So this is all about the single slit. Thank you.